Hello friends, welcome to Engineering Academy. In this video we will see how we can calculate the quantity of rebar, or you can say steel, in a beam. And to get the full courses of Engineering Academy channel, please check the description. In this video, I'll be using a basic beam, just an example beam, or not a real beam. Once you understand this, in the next video, I will talk about a real beam and how actually we calculate the quantity of steel when we prepare the running builds at the site. This is just an introduction video to get the basics of the concept. So let us take a beam as an example. If I draw the plan of the drawing, so this is the plan. So this will be our column. So this is our column 1. So this will be our column 2. And this is our beam. Okay, not very accurate. And this is our beam. Suppose the columns, so both columns are same. And suppose that the column size is 400 mm by 400 mm. And so we don't need the reinforcement of the column. So these both are the columns, and let us take so this is the center of the column, and this is also the center of the column. And so let us take this span as 5 meters. If I draw this section of the beam, so section AA, what I will see, so I will see a beam. So this is our beam. This is the slab, this is the thickness of the slab, and this is the thickness of the beam. So thickness of the beam is always including the thickness of the slab. So let us take this as 400, again 400, and let us take this width of the beam as 230 mm, and this is 400 mm. So depth of the beam is 400 mm and the width of the beam is 230 mm. And now let me add the reinforcement. So it has got 2 bars at the top, 2 bars at the bottom. So these 2 bars are 16 mm bars, and these 2 bars are 12 mm bars. So they are 12 mm bars. So 16 mm bars at the top and 12 mm bars at the bottom. So it also has got the stirrups. So let us add the stirrups. Okay. So this is a 2-legged stirrup, and this is the hook. So now stirrup we will use 8 mm. So 8 mm stirrup at 100 mm center to center. So this is the detail of the beam, and if I draw this section, this longitudinal section, so let us take this section as section BB. So this is section AA. Now if I draw the section BB, so BB section will look like, so this will be our column, this is our beam, and so this will be the reinforcement. So these are the 16 mm bars, they will be 2 in numbers, and we'll also have the 12 mm bars, that will also be 2 in numbers. So these two 16 mm bars top, so these are the 16 mm bars, 16 mm, and these are the 12 mm bars, 12 mm. So this is section BB. So this is a 2-legged stirrup, and this is the hook. So now stirrup we will use 8 mm. So 8 mm stirrup at 100 mm center to center. So this is the detail of the beam, and if I draw this section, this longitudinal section, so let us take this section as section BB. So this is section AA. Now if I draw the section BB, so BB section will look like, So this will be our column, this is our beam, and so this will be the reinforcement. So these are the 16 mm bars, they will be 2 in numbers, and we'll also have the 12 mm bars, 12 mm bars, that will also be 2 in numbers. So these two 16 mm bars top, so these are the 16 mm bars, 16 mm, and these are the 12 mm bars, 12 mm. So this is section BB. Now let us find the quantity of steel. So let us first do the main bars. So main bars, so we got main bars as one is 16 mm bar, 16 mm bar, okay. Number of bars is equal to 2. So length of each bar is equal to, now we need to find the length of the bar. And if you see this drawing over here, we know that the length from this center up to this center is 5 meters, okay, and this length is 400 mm, that is 0.4 meters, 0.4 meters, and this is also 0.4 meters, that is the width of the column, isn't it? From here to here it's LD, that is the development length, LD. On this side also, from this face of the column up to its end, it's LD, okay. And if I add this inner length from here to here, this inner length, plus if I do 2LD, if I add 2LD, I'll get the total length of the rebar. So let me say again, from the face of the column up to the top of the rebar, okay, let me change the color. So from the face of this column up to the tip of this rebar, this length that you can see over here is the development length. And also here from the face of this column, that is here, up to the tip of this rebar, this is also the development length. And if I add 2 development length plus this inside to inside dimension, I'll get the total length of the rebar. Total length of each bar is equal to, so 5 meter minus the 5 meter is from the center to center distance. So if I subtract half of this column width and half of this column width, I'll get here to here, okay. So I'll do that. So it's 5 minus 0.4 by 2, half of the column width, minus 0.4 by 2 plus 2 times of LD. So this is now 5 minus 0.4 plus the LD. So LD is the development length, and so it is so we got the formula for the LD, and you can find this formula in your Indian Standard Code or any code that is followed in your country, and from using that formula you can get the value of LD. And generally if you check the structural drawing at the site, so if you check the structural drawing at the site, so the LD will be specified there. So how much LD you should take, the development length you should take, will be specified in the structural drawing. So I'll take LD as 65, not 65, 65, where 60, this factor we get from the formula, okay, from the formula, and phi is the dia of the bar. So this is in mm, and if I convert it to meter, it will be 0.06 phi. So phi here, the phi is 16 mm. So place this is in mm because I have already converted the factor to meter. So now if I calculate it using the calculator, so it turns out to be, so if anywhere I do the calculation mistake, please correct it by yourself, okay. So plus 0.06 into 16, so this is equal to 5.56 meters, 5.56 meters. So total length of 16 mm bar is 2 into 5.56 is equal to, so let me multiply it with 2. The answer is 11.12 meter. Now if I find the quantity of steel, now if I find the weight in kg, so weight of 16 mm bar. So we know that the formula for weight per unit length is phi square by 162 kg per meter. Phi is the diameter of the rebar, and so this phi square by 162, the value you get is the weight of that rebar, in 1 meter. So we got total length as 11.12. so we simply need to multiply it, phi square by 162 into 11, that is equal to, so phi square by 162 is it's kg per meter, so the unit has already been converted and you have to place the unit here in mm. 16 square by 162 times 11, this is equal to, okay, let me again use the calculator. So 11.111, okay, sorry, it's 11.12.12, and so if I multiply this with phi square, that is 16 square by 162, and the answer is 17.57. so 17.57 kg. Total weight of the 16 mm bar in our beam is 17.57 kg. We got one value. Now you can do the same thing for the 12 mm bar as well. So what you should do now is that you pause the video and calculate the quantity of 12 mm bar. So you have to do this, and once you do that, please write your answer in the comment below. So all you need to do is find the total length, and after that use phi square by 162, where phi you have to put the value as 12 mm, and after that you will get this value. Okay, let us calculate for the stirrups. Okay, so total quantity of stirrups, so quantity of 8 mm stirrups. So the 8 mm stirrups, these stirrups are placed at 100 mm center to center, which means that if this is your beam like this, okay, the first stirrup will be placed on the face of this beam, and after that 100 mm second stirrup, after 100 mm second stirrup, third, fourth, fifth, sixth, and it will go on. So normally the stirrups are placed closer up to a distance of 2d, where d is the total depth of the beam, and here also 2d. They are placed closer and farther apart in the mid portion, but here I have taken the uniform length just to make the calculations easy, and we will see this accurate thing or this real thing in our next video. Before moving on, I'll just give you a small concept. Okay, alright, so let me draw a simple beam here, and let me assume that this face to face distance is 1 meter. Okay, and let me suppose that I got 3 stirrups in this region. So the first stirrup will be placed here just on the face, second stirrup will be placed here just on the face on the other side, and the third stirrup will be placed at the mid portion. So by doing this, the distance from here to here will turn out to be 50 cm, and from here to here it will turn out to be 50 cm. So 50 plus 50, 100 cm, that is 1 meter. Let us see this in the reverse order. Let us assume that we know the spacing, and now we have to calculate the number of stirrups. So in this case, if I divide the total length, by spacing, then what I'll get? The total length is 1 meter, that is 100 cm. So 100 cm, okay, so 100 divided by 50 cm, this is, what is 2? The value is 2, isn't it? So by doing this, what I get the value as 2, and this 2 is the number of spacing. we got one spacing from here to here, and we got another spacing from here to here. But we don't need the number of spacing, we need the number of stirrups. So you see that number of stirrups is 3. So which means that if I add +1 to the number of spacing, I'll get 3. That is the number of stirrups. So this is the concept of dividing this thing. Okay, so you must have seen this formula somewhere, which means that if I have to get the number of stirrups, so number of stirrups is equal to total length divided by spacing plus 1. So if I use this formula, I'll get the number of stirrups. Okay, so now let us do for our example. Let us do this thing for our example. The total length in our case is equal to in our case is the 5 meter is from center to center minus 0.4 by 2 minus 0.4 by 2 is equal to 5 minus 0.4. So 5 minus 0.4, because 0.4 by 2, 0.4 by 2 will be 0.4, and this is equal to 4.6 meter. Now number of stirrups is equal to 4.6 divided by spacing is 100 mm, that is 0.1 meter plus 1. So if I do this, so 4.6 divided by 0.1 plus 1 is equal to 47. The number of stirrups is 47. Now I have to find the length of one stirrup, and if I multiply the length of one stirrup with the total number of stirrups, I'll get the total length of stirrup made by all these 47 number of stirrups. So length of one stirrup, let us find length of a stirrup. So length of a stirrup, if we see the section of this beam, so I'll just draw the beam and not the slab this time. Let me draw a beam, so it must be something like this, and let me draw the stirrups. Okay, this is the beam and these are our stirrups, and these are our 16 mm bars and these are our 12 mm bars. Okay, now I'll change the color. This depth we got as 400 mm, and this we got as 230 mm. Now we know that from here to here is the clear cover, and from here to here is also the clear cover. From here to here it is also clear cover, and from here to here it's also clear cover. So clear cover, that we can call CC, is equal to, for beam we can take 25 mm. Now to calculate the total length of stirrup, what I need to do is that, if this is my stirrup, so suppose that this is the stirrup, this is the rebar of the stirrup. Okay, this is the rebar. So this will come bend like this, this will go up, it's not that accurate, and it will bend like this. Okay, this is the rebar, stirrup rebar. This is of 8 mm dia, 8 mm dia. Let me show you a real rebar, it will be much more clear to you. And you can see that this is 8 mm, and this is the hook, and we got alternate hook. So if we got hook at this position in this stirrup, in the next stirrup hook should be here. So I have just drawn this stirrup here. All right, so this is 8 mm, this is 8 mm, that is the diameter. Okay, so what I need to do is that I need to find the length, inside to inside length. Let me call this as A. I need to find the height, inside to inside height. Let me call this as B. Now all I have to do is that I have to add A. So this is A here, here is also A, so I have to add 2A. So this is B this side, and this side length is also B, so I have to add 2B. So this is 2A plus B, I must say. A plus B, the upper one, the lower one, the left one, the right one, so twice. Plus for these hooks I have to add 24D, 12D for this one, 12D for this one. Now I have to find A and B for our case, and if I go here, so this total length, now let us find the A. A is equal to, this total length from outside to outside is 230 mm, so it's 230. Now I have to subtract minus 2 clear cover, 2 cc, so clear cover here and clear cover here, minus 2, 5. So if I subtract then the diameter, this diameter, and if I subtract this diameter, I'll get the value of A. So this is equal to 230 minus 50, 2 into 25 minus 2 into 8. So if I do that, you must have calculated it manually already. It's quite easy. 2 into 25 minus 2 into 8. 2 into 8. Yeah. Okay, all good. So it's 164 mm. It's 164 mm is equal is equal to 0.164 meter. Similarly, if I find B is equal to 400 minus 2 into 25 minus 2 into 8, using the same concept. This is equal to now, so 400 minus 2 into 25 minus 2 into 8, 334 mm is equal to 0.334 meter. So now let me put this thing into the formula. So 0.164 plus 0.334 plus, okay, so I have to convert the unit here as well, 24 into 0.008. So just dividing 8 mm by 1000 to convert it into meter. So if I do this, calculation here, okay, let me do this one. Open the bracket, 0.164 plus 0.334, close the bracket, plus 24 into 0.008. This turns out to be 0.5268 meters. 0.5268 meter for a single rebar. So this is the total length. This total length, if you start from here, if you go like this, and if you take this entire length, so this entire length will be 0.5268 meter. Now, okay, now I'll use the green. Let's go green. Now the total length is equal to 47, that is number of rebar, times 0.5268. so this is the number of rebar, this is the length of each stirrup, number of stirrup, length of each stirrup. So this is equal to into 47 equal to 20, how much was that, 24.76, okay, 24.76 meter. Now total weight is equal to 5 square by 162 into 24.76 kg per meter into total length. And if we do this, this will be 8 square by 162 into 24.76. This is equal to, how much is it? Okay, let me multiply this with, let me use this one, 8 into 8 divided by 162. This is 9.78 kg. 9.78 kg. So we got the total weight for 16 mm. 16 mm we got the weight, let us call that A. For 12 mm we got the weight, let us call that B. For 8 mm we got the weight, let us call that C. Now the total weight of the rebar in this beam is A plus B plus C. Okay, A plus B plus C, let us call this answer as D. Now if you need to find the you see the total cost of rebar, total cost of rebar will be equal to total kg into rate per kg. So generally right now in Nepal, I think it's let's say 70 rupees, Nepali rupees, and so let us take 70 rupees per kg. So rupees, this is NRS. So suppose if we find this value as, let us say 50 kg, 50 into 70, that is 3500 rupees, 3500. That will be the total cost of the rebar. So I hope you learned something from this video. Keep learning and take care.